Start the summary. All right. I've started all the things. And start there. All right. Thank you guys for being understanding last week. Like I said, it was my son's graduation. There was a lot of stuff going on. So very busy week here as he gets ready to serve his mission in a couple months. He's putting his papers in end of next week, end of week after next. So very busy time here. Let me go ahead and share my screen. So before we begin, are there any, we were in week 6. We're in week 6 here. Does anyone have any questions on what we've covered to this point? Anything on joins? Anything on anything?
I'm kind of a slacker. This is the first time I'm coming to these meetings, but yeah, I remember you saying something about the essays in the final. What was the deal on that? You either do
So
essays
sure,
or you do a final?
sure. Great question. So, if you're choosing to do the final project, then the essays that you do every week will be based on your final project, not the question that's there. So like this week's question is something about, I don't even know what it is. Something about joins, and how they work or something like that.
Gotcha. But
Yeah,
so
so
so either way, you have an essay every week. It's just whether it's
yes,
about the project or it's about, okay, sounds
correct,
good.
correct. Yeah,
That's
so
all I was
if
wondering.
you're doing the final project, then write about the final project. If you're not doing the final project, write about that. If you are planning on doing the final project, write the papers as if you are, and if you have to change your mind at the last minute, you won't be penalized. It's totally fine that if
Okay,
you change. We're real flexible here. Well, I'm real flexible here.
cool, awesome. Yeah, just make sure I'm doing it right. Thanks.
Yep. There is. I don't know if I don't know if it's you. Someone is like doing the essay based on the prompt and then writing about the final project. I don't know if it's you or not. Someone is doing that. I'm like,
That's not me, but that sounds
yeah.
like extra work.
Yeah, I'm like, don't do that. You don't need to do that. Also, I don't know if anyone here is doing it, but if anyone actually watches this after I post it and you're not here, you don't have to use you don't have to use the CLI. It's not part of this class. If you want to do it just for fun because you need to feel challenged, cool, but please just use the workbench and make your life so much easier. All right. If there are no questions, I'll move on the code for this week. If we have time, we're gonna do a little database design. If not, we'll do that next week. We're at week 6, so these meetings as they stand now after week 9 stop. And week 9, 10, 11, and 12 are only I'll log on specifically to see if anyone needs help with their final projects. Because let me do this. So once I explain the code that I'm going to go through today, I will actually have given you all the code you need for the rest of the semester. Plus things that aren't even mentioned. So I wonder if there's anything I forgot from. Let me see something here real quick. Hang on a second. I wasn't here last week, so let me get my week 5 code to make sure I didn't miss anything important there. 1 second. Okay. No, I don't think I did. No, week 5 we did already. Okay. Yeah. Okay, good. So I did week 5 already. Cool. I did week 5 and week 4, and now I'm week 6. Okay, that works. All right. So let me share my screen. Let's get this party started. And we're gonna share the entire thing. And we're here. Okay. So today in the coding, what we're talking about the remainder of the DML codes, data manipulation language. So DML is data manipulation language. It's how you mess with the code, the data that's in the tables. DDL is data definition language. It's the code that we use to create the schema or the tables and stuff. So I'm going to start here. I'm just going to show you a quick, I got to use Sakilla first. Okay, so Sakilla, drop table persons. Okay, so just real quick, here's a quick code on creating a table. I'm going to create a table for the purpose of demonstrating stuff today. I'm creating a table called person. It should be person, not persons, but I've done all the code for persons, so that's fine. I got a person ID. It's not null. It's auto incremented, which means once it has value, it will do the next one available. I have last name varchar 255 not null, and first name. Oh, you know what I haven't talked about here? Okay, let's talk about this real quick. So data types, this is a tangent I usually go on during week 5, and I wasn't here for this. So here's the thing. So I'm talking about this here. When we talk about designing a database and we talk about how we design the tables, there's a lot of things we have to keep in mind. But the most important thing we have to keep in mind is how much space that database will take up on the disk drive. Because in the world, as it stands today, the most expensive peripheral for databases and computers in general is disk space. Now, you might say to yourself, hey, I can go to Best Buy right now and pick up a 4 terabyte drive for $99.95, and that's all fine and good. Well, yes, you can. I think you can. 125 maybe. But when we're talking corporate structure, when we're talking about like enterprise level stuff, we're not buying the USB drives from Best Buy. We're buying drive banks. And those little drives don't come in 4 terabyte sizes quite yet. They'll come in 1 terabyte or 1.5 terabyte. And we buy like 100 of them across one thing. So if you imagine, I don't know if anyone's ever seen what a server room looks like with the racks, but you're talking like something like this, like a filing cabinet that goes from the floor to the ceiling, and the drawers there are just full of hard drives, right? And those can get very, very expensive because right now we're talking everyone wants to do solid state drives. They don't want to do the disks anymore, do SSDs. So that's very, very expensive. And then you've got different speeds of hard drives. You've got the super fast hard drive, you got the regular hard drive, you got the super slow hard drives. And we want to make sure our databases live on the super fast hard drives. So when we're talking about storage on disks for database, it can get really, really expensive. You could be looking at $5,000 or $6,000 a terabyte, depending on your company and how much data you have and everything like that. So your database, if it gets huge, will be eating up a lot of disk drive real estate. So it's very, very important that when you design your database and you design your tables, you do it in a way that it will minimize the space, but maximize the potential, right? And what I mean by that is to kind of take into a sidebar. When I taught public high school for a long time as a drama teacher, and I really loved it. And I was involved in the building of other schools. They would ask me questions and things like that. And I was on a consulting group, I guess you'd call, for one school. And they're building the school to house 3,000 students. And I remember this conversation because on one of the meetings we had, we knew that opening day enrollment would be 4,500 students, but the school is only built for 3,000, so they poured in 2 or 3 dozen portable classrooms. So I asked them, I said, why would you build a school for 3,000 students when you have there are 4,500 coming in minimum? And their response was, it is easier to add on to an existing school than it is to build a school for the number that you actually want. I thought that was stupid, but that was just me, and that was their logic. So when we're looking at building a database, we need to make sure that it's going to be big enough for what we think it's going to be used for, but we want to make sure it's not using too much space. And that all comes down to the data types that you choose. That's why data types are such a critically important thing. Now, something as simple as int. So we've got int, right? But we've also got tiny int. Let me put these in order here. We've got int, we've got tiny int. We've got small int. We've got int, and we got big int. I think it's big int, right? Yeah, okay. So now, these are all integers. So there's all whole numbers. But depending on the size of it, now if I might be wrong on these sizes. So I think this one's 8-bit, this one's 16-bit, this one's 32-bit, and this one's 64-bit. Okay. So 8 bits in a byte, 1024 bytes in a kilobyte. You know, I don't know if you know the math, but that's the math behind it, right? So now a tiny int goes from negative 256 to positive 256. Small int goes from negative 52,000. These I'm gonna guess at these numbers, but you'll understand what I'm talking about in a second. To positive 52,000. Int goes from negative 2 million ish to positive 2 million ish. And then 64 goes like, it's just ridiculous. It's like, 64 billion to whatever, right? So that big int it takes up everything else, right? So now what this means is when you have a row of data and you've got each cell in there, that first cell let's use person ID here for instance, right? Person ID, that first cell is going to take up 32 bits no matter what's in there. It could be the number 0, it could be the number 1.8 million, it could be whatever. But that is going to take up 32 bits. Now, you think that's not a lot. 32 bits is not a whole lot until you have, 2 million rows. So when you have 32 million, so you've got, let's say you have 190 million rows, right? And you multiply that by 32 bits. You divide that by 8, and you divide that by 1024. It's 7,000 kilobytes. So it's 7 gigabytes, right? So that alone, that column alone, with 1.9 million rows, is 7 gigabytes by itself. Forget the rest of the rows, right? So you're planning on, so if you have this column in here and it's an int, you're saying that I plan on that at some point being around 10 gigabytes just for that column. Forget everything else, just that column, right? That's a lot of space. That is a lot of space. And when you're looking at 50 tables with 1.9 million rows, all with int in that first position. So now all of a sudden, 7 terabytes becomes 7 gigabytes becomes 3 terabytes. So all of a sudden, these databases can get really, really big, really, really fast, right? So when you choose your data types, you need to make sure you're choosing something that makes sense for that data type. For example, person ID, okay? How many people do you anticipate being in your table? How many people do you plan on your company having 2.2 million customers in some capacity? Then maybe int is the way to go. And I'll tell you a story. One of the first companies I worked for had a database. They were a property insurance company, and they would investigate, they would research property insurance when you buy a house, right? And every time someone came through to do a research, there was a transaction, and that transaction was recorded in a database in a table called the transaction table. And every transaction had an ID number, right? So the company opened, I started working there about 6 or 7 years after the company opened. And so let's call it 7 years. And when they designed the database, they used int as their ID for the transaction table. The problem was 7 years in, they were like 1.9 million rows in, and they were on track to run out of integers, run out of numbers in about 6-7 months. So that was a problem, because here you have integer, it ends at around a little over 2 million. And once that limit is hit, you can never put another row in there again. You can't put that, you'll break it. It won't go. So we had to take a 3-day outage for this. And we had to convert this int to a big int. Okay. And now if you look here, ints are 32 bits and big ints are 64-bit, which means we doubled the size of that column. So it went from 7 gigabytes to over 14 gigabytes. And that is a lot of growth for a database. It messes a lot of things up when that happens. And we were offline for 3 days. We lost business for 3 days to make that happen because there was no other way to fix it. And here I am 2 years later, and there still was no other way to fix it other than just go in there and change the data type in the table. Because what happens is when you go into your table with data in it and you make a change, it goes, there's a phrase I use called RBAR. So it's RBAR. It's an anagram, means row by agonizing row. So if you've got 1.9 million rows in this table and you change that into a big int, it goes to every row one at a time and says, you're a big int, you're a big int, you're a big int, you're a big int, and so on. So 1.9 million times, that takes a really long time to do, and nothing can happen because when you're growing the table, you're growing the index. When you're growing the index, you're growing every other index. So that double in space, that 7 gigabytes, because of index space, because primary key space, because of tertiary index space, your 7 gigabytes ended up being more like 25 to 40 gigabytes of space that you had to reconsume because you changed the database, the size. Right?
Did you have to manually go row by row and change that?
No,
Or
no. We
that'd
just
be miserable.
oh gosh, I would have no, I'd still be there. But no, I just wrote code to do it, and I just hit the start button. I had to watch it for 14 hours to make sure it didn't crash, and then I had to rebuild indexes for another 12 hours after that. But no, it does it automatically. But so this is why when you're designing databases, even and kind of keep this in mind if you're doing the final project, make sure you're choosing the right data type for what you're trying to do. So if I'm doing an ID, right, and it's for a company, it's completely possible that 2 million is in there. So I don't mind using int for a person ID. But if I'm doing age, I shouldn't do int because last I checked, 2.5 million is not an age anyone can achieve. So I'd probably do TinyInt. Because just because no one's reached 256 doesn't mean it's not gonna happen. But I'd probably do age as a TinyInt. Is that all making sense about the sizes and stuff? Give me a thumbs up if you got it, if I'm making sense. Sweet. All right, cool beans. So with int, we've got decimal, we've got float, and all these other ones. See, they're all, and all of the ones that are numeric have specific sizes that they maintain. So there's a chart somewhere. I can if I can't find the link, just Google data type chart, and it'll tell you the data type, its size, and what it entails as far as numbers concerned. There's also date, there's date time, there's time. These are all data types that have specific sizes because a date is going to have a specific size. Date time is going to have a specific size. Int's going to have a specific size. Okay. These are all numeric. The ones that we have that aren't numeric are our chars. And there's char and there's varchar. Okay. Char just means characters. Varchar means variable characters. So, and with char and varchar, there's always parentheses in the number that follow. Okay. So if I do char 25 and varchar 25, right? And let's do a last name. My last name here. And I've got first name. The difference between char and varchar is if I say char 25, when the space for that row is delegated on the drive, that column for last name is going to be 25 characters, 25 bits big. Okay. No matter what you put in there, if you put a letter A, you put nothing, whatever it's going to be, that space is going to be 25 characters large. If I do varchar, it can be anything from 0 up to 25. Okay. The standard one for varchar is 255. That because that holds most last names, addresses, and stuff like that. Okay. And the reason for, and so I'm not going to get into extents today. I'll talk about that later. But so that's the thing. So again, when you're choosing the data type for your text files, you want to make sure you're using char varchar and make sure you're using the correct amount of numbers. Like if I'm going to do last name, I want to do varchar, first name char varchar 255. We're not going to see over 255. If I want to do something that would have a set, like if I did state, right? If I had state, I could do char 2 because it's always going to be 2 letters. Okay. Now keep in mind, the reason is, and keep in mind, the other thing is, if I do char 2 and someone tries to put in the word Utah, it's going to error out saying it's incorrect. It'll have a buffer overflow error, I think is what it is. Okay. That ends the sermon on data types. Does everyone did it make sense on data types? Right, I'm going to assume the answer is yes, unless someone stops me. Okay, so here I'm going to create a quick table. Person ID int not null, which means there must be a value in there. Auto increment, it's going to number for you, so I don't have to keep it in the insert statement. Last name is varchar 255 not null, which means it has to have an entry in the last name. First name varchar 255, I don't have not null, so it can be null. The first name can be empty. Tiny age, tiny int. I'm setting it to not null. It can be allowed. It'll allow nulls, and I'm setting the primary key to be person ID. Remember, the primary ID has to be unique, and just unique. I was going to say not doesn't repeat itself, but that means unique. So I'm going to go ahead and create this table. Okay, and the table has been created. Now, when I write insert statements, because here's the insert statements again, insert into the name of the table, and then you've got the values command. Okay. So we got into persons, values, Williams, Venus, 27. Now, if you look here, I've got 4 columns, right? But I'm doing 3 values here. If I run this, it should error. Okay, because it says here column count doesn't match count at row 1. Okay. So if I just do an insert statement like this, say insert into persons, it's going to assume I'm going to give you values for all 4 because I'm not specifically defining what columns to go into. In my insert statements, I can tell specifically what columns to insert into and which ones not to. It doesn't matter the order I do them in. It doesn't have to match what the table has. Okay. So if I do this one will fail. If I do this one's going to go just fine because I have all 4 values, 16, Williams, Venus, 27, right? Person ID, last name, first name, age. So if I run this one, it'll go just fine. When are affected, insert, so I'll do select from persons. Okay. And there's my 1 row. Here I've got insert into persons, but I've got 6. Sorry, this one I've already done. So let me comment these out. Okay.
Can I ask a question?
Sure, go ahead.
Okay. You have it as auto increment, but then you put the number 16 in. How does that work?
So in MySQL, I can put a number in there for auto increment, and that's the number it's going to start at. So the next one will be 17 is 18. In MySQL, I'm sorry, in SQL Server and in Oracle, auto increment is the command. It's called identity. And an identity, that is a column you cannot insert into on your own.
Okay.
But MySQL allows it to happen. Okay.
Okay. All right. Thank you.
No problem. So now here for this next one here, I've got insert into persons, but now I've got last name, first name, and age. Right? So I'm saying Williams, Tennessee, 27. I'm saying just these 3 rows. And because person ID is auto increment, I do not have to include it here. And it'll take up to the next one, 17. And like I said, it doesn't have to be in the right order. I have insert in persons, age, last name, first name. 102 Williams Willie. Again, it works fine because I've told it what to insert into. I didn't need to give it person ID because it is an auto increment. Okay. Jump down here and grab this one here. Okay. Bring these up here. Okay, I want to grab these 3. Okay. Okay, so into here. So now you may say to yourself, so here we got into, yeah, so here. Now, if I try to do this one, I've got insert into persons, person ID, last name, first name, age, 16 Williams Venus. And all this thing here is just a fancy way to give me a random number between 1 and 50. So that's just a fancy mathematical thing, right? But if I try to do this and I run it, I get an error. Duplicate for 16, person's primary, it's already there. Okay. So once the value is already there in an auto increment, it's going to break. If this wasn't 16, if this was 116, it's going to work because auto increment allows you to put things in even though it's auto increment. And then the next one will be 117. So I go here and select from persons. And I've got, right. And then if I inserted this one again, oh, it goes to 17. Okay, so it goes to 18. So it'll keep going to the auto increment and last one if you put in a random number. But it will break when it gets to that one. Okay. Now, you're looking at this, like this is R bar. I don't want to do this every single time. I can write the statement this way, insert into persons, last name, first name, age, and then put in values and as many as I want to do. So here I've got 4, I could do 10, I could do 30, I could do whatever. And if I run this, everything will get inserted and it'll work. Okay, so I got 16, 17. So now it's picking up from that 116 now, right? I can also insert by using a select statement from another table. So here I'm selecting low. So lower here, what lower means, it just means the entire thing's gonna be in lowercase. So if I run this just real quick for you to look at, it's just gonna be the last name and first name in lowercase. And then here's my just random number. I just need a random age. Okay. So when I run this, I'm inserting the person's last name, first name, and age. And I'm doing this select statement. So all this is going to go into insert into the person's table. I'm going to insert 201 rows. I'll do my select statement. And there we go. All these things are here now. Okay. Insert statements are very cut and dry. It's insert. I can do a select statement to insert any. I can do a multiple join table to get me a result set and pop that into a table. The one thing that you'll want to know if you're doing the final project is I've got my persons table here. Where are you, persons table? Let's refresh. If I right click persons and I go to send to SQL editor and I go to insert statement, it's going to write the statement for me. So all I gotta do is put the values in here. If you ever need a template for a statement, just right click and go to that and you'll get your template. So insert statements, put the data in, update statements, change the data that's there. The wording for that is update and then the table name, what column you want to set, what you want to set it to, and the criteria by which you set it. Okay. Oh, I need to, before I do that here, here we are. All of this stuff up here. We'll get to that. We'll get to that. That's gonna be fun stuff. Okay. So here we go. So I got search. I said, I don't want that. I'm back here. So we're back here. So here, I'm going to update the person's table. I'm going to set first name to the upper class for first name. I'm setting all the names on first name upper class where the ages are between 12 and 25. So I'm going to run that. Oh, hang on a second. I did put a where clause in there. What are you doing? What's this error? Disable safe mode. This always happens every year. You think I've learned by now? Copy response. Drop down here real quick. Toggle the option and preferences. Okay, so see what's happening here? I'm using safe mode. I'm using safe update mode. I tried to update a table without the where clause that uses a key column. So here I'm updating based on the age column, and that's not a key column. So I'm going to change this to where person ID. It's actually it's frustrating for me to do this in class, but it's good to know that in MySQL there are protections in place for you to not screw up your database. Because I've done update statements and delete statements where I've accidentally deleted tables. And I'm going to show you how not to do that. But it's good to know that's here. Select person ID from persons. Okay. So fix that real quick. So I got this subquery in here. I'm selecting person ID. There we are. I'm gonna go ahead and update persons, and now it'll let me. You can't specify target table for persons from an update from a from clause? What are you talking about?
Maybe it's talking from earlier when you made the additionals when it went from 12 to 168. It's referring to.
Maybe I don't know. This is a weird one. This is a new error on me, so I don't know what I'm doing wrong. Let's just turn this off here. Disable safe mode. Toggle the option preferences. Okay, so what I'm going to need to do here is tools. Where's my options? Options. Tools. Configuration. Nope. Server status. Options. Files. Now the option preferences, SQL editor, reconnect, SQL editor. This is not where I want to be. Funny enough, I never mind making mistakes when I'm in class like this because it shows you guys it's okay to make mistakes. I've been doing this a bunch of years and I still make mistakes from now on time and time again. And it's totally fine to make mistakes. Preferences. Okay, so preferences, SQL editor. And I want to turn off toggle the option. SQL editor, query editor. Save snapshot, 10 seconds. Store the data. Toggle the option preferences, SQL editor, reconnect. Here's where I am. Ah, there it is. Turn that off. Okay. Let's open everything back up. Okay. Use Sakilla. Let's make sure it's off this time. Preferences going. I just thought a second ago. There it is. Preferences. SQL editor. Okay. Okay, so let's go ahead and disconnect this file. Close connection. Okay. Did it stay off this time? Yes. Okay, good. Okay. So it's off now for good. So I go here, go back to what I had going here and back to the way I had it. Here we are. Okay, now. There we are. So we changed 56 rows. Okay. So if I do my select from persons and I scroll up and down, there's Grace, Matthew, 0. All these people have upperclass name or uppercase names. Okay. Again, it's very, very nice that you've got this default protection there because we all make really dumb mistakes. Here we go. Another one. We're going to update persons, but this time we're going to interjoin it with customer. And I'm going to set the person's last name to the person last name. Sorry. I'm going to interjoin on the person's last name to the customer last name. And where they match, I'm sending the H999, 9,999. Which isn't going to work because this is tiny int. So I'm going to change this to 250. All right. And run that. Okay. What is it? Tiny int. Let's change it to 99. There we are. And I changed 52 rows to 99. Go here. And there's my 99s there. And there's some 99s there too. Okay. So with updates, you can update just straight left. You can do updates and joins. The next one is called delete. Deletes the same thing. It just deletes what you tell it to delete. Here I got delete from persons where last name is like F. I run that. It deleted 2 rows because only 2 last names are like F. Delete persons from persons interjoin customer where person last name and customer last name are the same. So up here where I did it where it's 99, I changed age to 99. Here I'm deleting where the names are the same. And deleted 52 rows. The same 52 rows I changed here. Okay. The last one here that we're going to talk about. So everyone with the updates and deletes. So now when I update and when I delete, it's R bar. It goes every row, checks it, updates what's necessary, and then goes on. If I say delete, it goes row by row, sees the row matches, and then deletes it. So if I've got a table of 1.9 million rows and I said delete everything that starts with an F, it's going to go row 1, no, row 2, no, row 3, F, no, no, yes, no, no, yes, 1 on. This table truncate. This truncate table flushes the table without checking. Now the reason, so now here's a quick, we got 15 minutes before we're out of time. Okay. So now did I explain to you guys about write ahead transaction logs? I'm going to assume I haven't. Okay. I need paint. Okay, so when we're talking databases, okay, so we've got our database here. This is our database. Okay. And then we've got our user over here doing their work, being a user. Now, you would think that when we put data into here and we send it over to the database, it goes from your screen directly into the database, but that's not what happens. Okay. So we've got something called a transaction log. And I would like a different shape, please. I will use this. Okay, this is my transaction log. This is my transaction log. Okay. So here's what happens. I write my data here. I send it. When I hit send, it does not go to the database. It goes to the transaction log. The transaction log makes the changes in the transaction log, makes sure they work, makes sure everything's good, and then sends it to the database. Okay. Now, there's a reason for this. If I'm doing it this way, where I'm just, let me put this in purple here. If I'm doing it this way, right, where I'm writing directly to the database, and let's say I'm inputting 5,000 rows of data, and here, blah, 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 R bar through, boom, boom, and the power dies at row 255, to 25,000, right? 2,500. When the database comes back up, it's not going to know anything's wrong because it was never warned what was going to happen. So it thinks everything's fine and dandy. You don't know that the data isn't there, and you've got what's called corrupt data or dirty reads because you don't know what happened there, right? The reason why transaction logs exist, if you have a transaction that's going to be 5,000 rows, right? You hit that send key. The first thing that happens, the database, your laptop goes to transaction log. Hey, transaction log, 5,000 transactions are about to come through. And it starts sending the transactions over. And for each transaction, the transaction log is going, okay, that one's good, 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 that's good. And at some point in time, it says, okay, it reaches its buffer limit. And it says, okay, guys, let's start going to the database. And let's say the buffer limit is 1,000. Okay. So once 1,000 rows are copied from here into the transaction log, they start writing to the database. So what happens, what this is a self-healing, self-preservation state for the database. Anything that gets put into the database file proper has to go to the transaction log to make sure it's correct. Okay. What this means is a couple things. If anything here is wrong, it's going to error out, roll everything back like nothing happened, and say, hey, there's a problem. But the important thing is, it's going to roll all the changes back. So if I'm 5,000 rows putting in and at row like 2972, there's an error, it's going to go, hang on, pull all those rows back out of the database like it never happened. The other thing is, if we're doing 5,000 rows and we're doing buffering and the power goes out and it comes back on, the database is going to say, hey, transaction log, it's called the LSN, the last serial number, right? It says, my LSN is 45,000. What's your LSN? And the transaction log is going to see what should have gone there, right? So the transaction log say, hey, mine is actually 48,000. Wait a second, you're missing rows. So then the transaction log looks at the last transaction that ran and said, okay, 5,000 rows were supposed to come in. You have 2,500 of them. I have the other 2,500. So I'm just going to go ahead and finish the transaction and everything's good as gold. So when the power goes down and comes back up, if the rows that were missing here are still here, it's going to copy them over and it's be like nothing ever happened. But if the transaction log goes, hey, there were 5,000 rows, you've got 2,500, I've got 2,000, we're missing 500, they'll go, nope, we're not doing this. And it will roll back the changes from the database as if nothing ever happened. And then give the error message to the user saying, hey, your last transaction didn't work. So the transaction log is extremely valuable. It makes sure that the database is always in a consistent and healthy state, as long as the transaction log is in a consistent and healthy state. Does that make sense? Because this is important to know for the next time I'm about to show you. All right. So now, with that being said, insert, update, select, and delete actions all trigger the T-log, the transaction log, to track what's going on. Truncate does not. Truncate bypasses the transaction log and just does what it wants. Okay. So how do we show that? So there is a code called start transaction. Okay. Every time you run something, well, let me do this here real quick. Let me do this update statement here, and then we'll actually do it here. So I've got this update statement here. I need to alter the table here first. Okay, let me alter the table here first. So I'm going to alter table, persons, add email. Okay, I think that should work. Okay, so now if I select star from persons, I suddenly have an email column that's empty. Okay. So I just altered that table, added the email column. I altered the schema. Now I need to fill that column. So I'm going to go ahead and fill that. I'm going to update persons. I'm going to set email. And I'm going to concat what I'm doing. I'm using concat. If you remember from like week 1 or 2, concat is when I take 2 text strings and put them together, 2 or more text strings put together. So here I'm concatenating the substring of the first name from the first character to the 4th character. I'm putting an underscore. I'm creating a substring from the last name from the first character to the 4th character, and then adding @gmail.com. So I'm going to run this to show you what it looks like. And I'm going to run this here. And I've got the first 4 characters of the first name, the first 4 characters of the last name, and I've added @gmail.com. And now I suddenly realized I misspelled Gmail. So I have a replace command that I can use. I can update persons. I can set email, and I can set email equal to the command replace. And I say, look at email, find this part of the string, and replace it with this part of the string. Okay. So I can do that, but I'm going to do that in a very specific way. So since week 1, you've seen me like highlight stuff and run it. And whenever I highlight something or run it or run a number of queries, that's called a transaction. You can have 1 command in a transaction, you have 30 commands in a transaction. It doesn't matter. Every time you hit that little lightning bolt, every time you run something, it's considered a transaction. I can control transactions. Down here, I've got start transaction. Okay. So what this says is, so what start transaction does is it tells the database, I'm about to do something, and I don't want you to finalize it until I tell you to. Okay. So I say start transaction, I have some code between, and then I've got 2 commands that follow it. I've either got rollback or I've got commit. Right? Rollback sends it back to the way it was. Commit pushes it to the database. So what that means is when I do start transaction, this only writes the transaction log. It does not complete the journey to the database until I tell it to. So I'm going to go ahead and start the transaction. I'm going to go ahead and update the persons table. You'll see 155 rows were affected, 150 rows were changed, no warnings. And if I do my select from person, you'll see that it's correct now. Then I hit rollback. And then you'll see it's not right anymore. Which makes you realize that the queries you're reading here are from the transaction log, not from the database. Because you remember on week 2, I said you can't touch anything on the disk. Everything has to be in memory, which means the transaction log resides in memory until it's finalized. So it's all coming together. At least I hope it is. Same thing here. I do start transaction. I make my change. I check it to make sure it looks good. And I hit commit. And now it's committed. Okay. Another example, I'm going to say delete from different persons where last name like W. I'll put that in my transaction here. I'm going to start my transaction. I'm going to delete for last names like W. 8 rows were affected. There are no W's. I'm going to roll it back. The W's are back. And then I'm going to do the same thing, but I'm going to take away the rollback here. Now, when I hit the insert key. Okay, run that now. And the W's are gone for good. Now, to show you what I mean by truncate, I've got this truncate table persons, right? I'm going to go here. I'm going to start my transaction. I'm going to truncate table persons. I'm going to select. It's all gone. I'm going to roll back. Still all gone. Transaction is the nuclear option to get rid of data. It is not tracked in the log. All you see is the transaction, the truncate table command, and then everything else goes away. It is a fast flush. And there's no way back from it. Everything else you do is tracked in the transaction log. If you know what you're doing, even if you change 10,000 rows, you can go into the transaction log and fix it. If you truncate, there's no going back. Suffice it to say, don't use truncate unless it's absolutely necessary. All right. That covers everything I had for tonight. We don't have time to run through a database design. We'll do that next week. I had forgotten that I hadn't gone through my tirade on data types and you got 2 tirades. You got the data type, you got the data type lesson, and you got the transaction log lesson. You just didn't get the fragmentation lesson. We'll do that next week or the week after on how index fragmentation happens. So are there any questions on the code that I've given you tonight? All right.
Makes sense. So
What you got, Alton?
that makes sense.
Oh, it does? Yeah. And like I keep saying, this is all English. There's no weird commands that come out of this. The error messages are fairly straightforward. So I will go ahead and get this converted out. I will send this, put this in an announcement. I'll put the code in the announcement. I'll put the AI's summary of this in the announcement. If there are any questions, please feel free to ping me, especially those who are doing the final projects. Other than that, if there are no other questions, I will let you guys go for the evening.
Yeah, it's just one more question.
Sure, go ahead. You guys, as many you want.
This was something from a while back, and maybe it was explained just barely, but yeah, I was just looking at the Sequila database. There's a table for films, and then there's a table for film actors, and then there's a table for actors.
Mhm.
I remember you saying something in the beginning of the class about, I guess my question is, what's the point of having the film actor table and not just have like films and an actor table? Is
Sure, that's sure. I will answer that. Okay, so let me pull up.
I think it was something, I think it was just one to many or something like that was the
Yeah,
deal, but I
it's
don't
one to
remember the
many.
exact answer.
So let me grab this here. I think this one will do it. Continue. Okay. So let's look at this table here. I've got astronauts and I've got missions, right? And I've got a table called mission astronauts. Let me get rid of this. Now we know astronauts go on missions, and we know that missions have astronauts. If I put mission ID here on the astronauts table, it becomes a many-to-many relationship, because one astronaut can be on many missions, and many missions might have the same astronaut. So I can't put mission ID here, and I can't put astronaut ID here because of the same thing. These tables have a many-to-many relationship. So they can't be directly connected, like this one here, right? A mission only has one destination. So I can have destination ID sitting in this table because there's only ever going to be one destination per mission. There's only ever going to be one launch location per mission. There's only ever going to be one spacecraft per mission. But astronauts per mission is always going to be many to many. So I need to make a many to many join. And that's where this comes in. Because now I can have all the astronauts and all the missions in one table here and maintain my one-to-many requirement as opposed to having many-to-many. Because astronauts, it's one-to-many here and one-to-many here. Does that make sense, Sam?
Yeah, okay. That
Yeah.
does make sense.
Yeah. And that's why when you look at something like film actors, one film will have many actors and one actor will be in many films. So the second you see that, you can no longer have a direct relationship between the two tables. It's the same thing with but as opposed to like, one film might have many categories and one category may have many films. But the way it's set up, the film will only be in one language, right? So we don't have to have the many table there. But that's why that's there. But that's a great question. That comes up, and I'm glad you asked that because I do explain that early on in the semester. But as people start designing their databases and they start doing that, they're going to start seeing this and they're going to try to make the many-to-manys work without doing that join table. So thanks for bringing that up.
Yep, sounds good. Thanks. Appreciate it.
All right. Any other questions? All right. I will see you guys in a week's time. Take care and be safe.